we're going to start with number 16, and I picked this one because I see a lot of common mistakes with this one. What it's asking us is to find the intersection of two planes. So I've already highlighted plane UXV, which would be UX, and then the V is over here. So that would make a triangle, and then just continue to shade that. That is our gold triangle. And then our pink triangle is WVS. Well, we have WV, and then we have an S here. Again, I always say if you have 3 points that make a triangle, you can continue to shade that to make a plane. Well, we want to find the intersection. This is where it's tricky. If you look at the picture, it looks like the intersection is just a segment. But we have to go back and think about the description of a plane. Well, this just represents the plane, but the plane in real life would just extend out in all directions infinitely. So that means their intersection would also extend out, and let me change this to a pencil, would also extend out infinitely. So the right answer would be, and let me make just this a little bit thinner, the right answer would be WV, not with just a segment over it, but you'd have to put the line. Let's look at the next one. Now we're going to do number 31, and it tells us that we have first to look at the first 3 points and then see if the fourth point would make these coplanar or non-coplanar. So looking at the first 3, it would be XZS. So going over here, we have XZS, so that's this whole gold plane right here. Well, we want to look at point V and see what happens. Point V is all the way over here. There's no way that we could connect all those points to make a flat surface. So these would be non-coplanar. And then looking at the next one is 34. We want to see if we can, if possible, draw a figure to fit each description. Otherwise, write not possible. We're going to do 34. Well, 2 points that are non-collinear. We have to go back to our postulate. And it says that through any 2 points, there is exactly one line. So if we have 2 points, no matter what, we can always draw a line between them, and then they would be collinear. So the answer would be not possible. The last one we're going to do is 43, and we're trying to figure out if this statement is always, sometimes, or never true. 4 points are coplanar. Well, the postulate says through any 3 non-collinear, and the key is 3 and non-collinear, there's exactly one plane. Well, 4, we don't know. We'd actually have to see it and see if we could connect all those to make a flat surface. Then they would be coplanar. So we're going to put that the answer for this one is sometimes, because we would just have to see it.